I have to say happy Wednesday and happy last day before Thanksgiving break. I know I'm going to miss seeing you guys over break, but I hope that it's restful and that you get, um, a break from all the crazy illness that's going around. That's what I'm hoping for everybody. So hopefully I'll see everybody back after Thanksgiving break or however it's going to be after break. But I really am just hoping and praying for everyone, just a wonderful, restful break, whatever you need with your family. So today we're going to do review for Chapter 5. So there's a Chapter 5 test that is supposed to be on this Friday. So I'm going to be posting that out today. My warning, if you're watching this video or if you're in class, I'm going to tell you the same thing. Do not wait to take your test until the Sunday night before Thanksgiving, or after Thanksgiving, because that's a long, long, long time away and it's a lot to forget. So just get your test done while it's fresh in your mind. You can use your theorem sheet, and then you can also use the center of circles sheet that we filled out in class and online. So again, just kind of get that done, get it off your list. You don't want to have to try to remember what a ortho center is after you've eaten turkey and pumpkin pie, hopefully, right? So that's what's going on. So today what I want to do is a review, and then we're going to play a game in class, and I'm going to explain that to you, send it over as well. So let me go ahead and pull up my screen. All right, here we go. So back to our centers of triangles. That's what I really want to review today because I think that's the trickiest part. And then I have a couple quiz questions because I'm handing back the quiz that I want to go over that seem to be tricky for a lot of people. So again, what I really want to focus on is center of triangles because I think that can get a little confusing for people. So I just want to make sure everybody's comfortable with the 4 different centers of triangles that we learned. Make sure you have your sheet filled out, and so let's talk about that. So I first want to talk about circumcenter. So remember, circumcenters are created by, would help if I have my right. They're created by perpendicular bisectors. Perpendicular bisectors, right? Bisector, sorry. All right, so, and sometimes we say perpendicular like that, right? Perpendicular bisectors. So the first thing I want to make sure that you remember is what is a perpendicular bisector? Okay, so I have some triangles below here that are blank, and if I said to you, draw a perpendicular bisector, could you do it? What are the 2 things that we need to know about perpendicular bisectors? Well, the 2 things that we need to know about perpendicular bisectors is that they're perpendicular and that they bisect the line that they're on. So if I look down here at this triangle ABC, and I look at line AC, the first thing I'm going to do is figure out where's the bisector, where's the midpoint of AC, and that's at point Z down here. Okay, so this is the bisector part that I just drew. So that means that from A to Z and Z to C, those 2 lines are congruent to each other. Right, so that's what's important about the perpendicular bisector, the bisector part. The second part is that it has to be perpendicular. So perpendicular means it has to be at 90 degrees. So if I was going to draw a line at 90 degrees, right, I would do that. And so that line that I just drew is a perpendicular bisector. Okay, so that's the first thing. When we're dealing with circumcenters, they're made up of perpendicular bisectors. And do you know what a perpendicular bisector is? Well, so we just talked about it. It's perpendicular at 90 degrees and it bisects the line that it's on. And so then you can see much more eloquently than I did, they have drawn the perpendicular bisectors up here on this triangle, right? So ZM, XM, and YM are the perpendicular bisectors because they're at the midpoint of their line segments and they're at 90 degrees, okay? And then the cool thing about perpendicular bisectors is that then the distance from the center to the outside vertex are all the same. So remember, in this case, AM equals BM equals CM. Okay, so the green is the perpendicular bisector that creates the circumcenter, and then from the circumcenter to the vertex, those are all equal to each other. So while I'm right here on or circumcenter, I want to switch over to the quiz because this question was a circumcenter question. And I had a lot of people get some of them right, but then there were some that kind of got confusing. So what I would like, well, what I'm going to do is I'm going to actually label this picture because it tells me in the diagram, perpendicular bisectors of ABC meet at point G and they're shown dashed. So they're telling me that the dashed lines are my perpendicular bisectors. It's really hard to see GF, but down there, by the way. So these are my perpendicular bisectors, which means that they're at 90 degrees, right? And that means that every segment that they have bisected is equal. So if I was doing this before I even looked over here, I would start labeling things. So I know that if point D is the perpendicular bisector of AB and A to D is 20, then D to B has to be 20. And I saw some of you guys labeling this, so just make sure that, I just want to make sure everybody's got this. So over here in B to C, E is the midpoint. So from B to E is 15. That means from E to C is also 15. Okay, and then down here from A to C, F is the midpoint. So A to F is 24 and F to C is also 24. All right, so that kind of helps me out with that, right? Now, the other thing that I know is that once I find the circumcenter, right? Once I use the perpendicular bisectors to find the circumcenter, then I go from that circumcenter to the vertices, I guess. Yeah, and those are all the same. Oh, I guess I should be making this a little bigger. Sorry, guys. There we go. I don't know if that helps you or not. But these are all the same from G to B, G to A, and G to C are all the same. So once I've found that circumcenter, then I know each of these lines is the same. Okay, so I did see some people that use Pythagorean theorem to figure out some things, and that's great, but actually in this problem you didn't even have to use Pythagorean theorem if you did that. So the only thing that we don't know the distances of in this picture are the actual perpendicular bisectors. So we don't actually know the distance from D to G, E to G, or G to F. We could figure those out using right triangles, but I don't think that that question even was asked on the quiz. So if I wanted to find A to G is the distance from the circumcenter to a vertex. And so that's 25 because all three are 25. I think everybody got that one. B to D, confused a couple people. B to D, we already know that from A to D is 20, so B to D also has to be 20. That's the definition of a perpendicular bisector, right? C to F again is the distance to the midpoint, which is F. So if A to F is 24, C to F also has to be 24. And then BG, so I had a couple people with BG, that one was confusing. So BG is also, remember, the distance from the circumcenter to the vertex. So it's 25 because they're all equal to each other. A to G is equal to B to G is equal to C to G. So that's kind of what's going on with that. That's how you would solve a problem using circumcenter. So I just wanted to make sure that everybody was on the same page with that and kind of understanding that, so it's not too confusing because we'll have questions about that. All right, the next center of a triangle that I want to talk about is the incenter. Okay, so the incenter is different than the circumcenter because with the incenter, what we're going to use is we're going to use the angle bisectors. Right? Bisector. I got lost writing. Angle bisectors. You get the idea, right? So the angle bisectors to find the incenter, right? A to M, B to M, and C to M are the angle bisectors because so we're starting with the vertex and we're bisecting the angles. So if I wanted to draw an angle bisector down here on my blank triangle, I'm going to draw a line that goes from A to the middle that bisects angle BAC. So basically, I want to draw a line that divides BAC into two equal parts. So remember, that's the definition of an angle bisector. So again, if I asked you what an angle bisector is, you should know that the angle bisector bisects the angle into two equal parts. So here's an angle bisector down here in purple, and here up here in purple are the angle bisectors labeled on my graph, right? All right, so the cool thing is once you find the angle bisector, which is M, and then you draw a line that is at the shortest distance, which means at 90 degrees to the sides, then all those sides are equal to each other. So in this picture, if I told you that M to Z was 10, okay, you would know, oh, then M to Y has to be 10 and M to X has to be 10. So, you know, you might have written down on your paper that XM equals YM equals ZM. The other thing that you should be able to do is say that I told you that angle BAM, angle BAM is 30 degrees. BAM is 30 degrees. Then could you tell me what angle CAM is? CAM. So if I told you BAM right here is 30 degrees, could you tell me what CAM is? It's also 30 degrees, right? Because they're angle bisectors, that means they divide it into two equal parts. Those two angles have to be equal to each other. So just don't forget that, you know, simple kind of math there, that if we know it's an angle bisector, that those two have to be equal. I'm going to erase this off because it's making it kind of messy on there. All right, so that is an angle bisector, and that creates the incenter. So again, back over to the quiz, there was one question about the incenter, and actually you didn't have to know a whole lot about the incenter to do question number 18, but let's just take a look at it, okay? So it says you are building a monument in a triangular park. You want the monument to be the same distance from each edge of the park. So remember, the incenter makes lines that are the same distance. Use the figure with incenter G to determine how far from point D you should build the monument. So they're telling you that G is the incenter, okay? And they want you to know how far from point D you should build the monument. So they want to know this distance here, which we'll call X, all right? So a couple of you did some really fancy math things and you did lots of labels, which is awesome. Yeah, I saw lots of different labels going on. So I want to tell you some things that you can't assume. Even though it looks like in this picture, you cannot assume with an incenter, you could not assume this is 120 feet. Even though it looks like it is, I know it looks like it is, but you can't assume that, right? That would only be if this was a perpendicular bisector, but the blue line that I'm showing right here is not a perpendicular bisector. What actually we could assume in this picture is that this angle right here, FBG, is congruent to angle DBG. And we could assume that DCG over here is congruent to GCE over here. And then we could assume that these two angles are congruent. So just so you know, from the fact that it's an incenter, right? That actually does not tell me anything about like those sides. So just be careful which one you're using. So back to the problem though at hand. So really with this one, what's happening is we want to find the distance from D to G, and you'll notice that this triangle right here is a right triangle, right? And so then we just use the Pythagorean theorem to figure out what X is. So we know that A squared plus B squared equals C squared, right? The hypotenuse is the longest side, which is across from 90 degrees, so 125. So we've got 120 squared plus X squared equals 125 squared. So when you do all that work, you get X equals 35. So the fountain should be 35 feet away. All right, so that's an in-center problem. All right, let's check on the last two. All right, so the last type of, or the second to last type of centers of a triangle is the centroid. The centroid is cool, right, because it is the center of balance on your triangle. So that's what makes it unique. All right, and the centroid is created by medians. So if I asked you to draw a median, could you do that? So a median means that we find the midpoint of one side of our triangle. So I'm finding the midpoint X, and then we play connect the dots, right? We connect from the median to the opposite vertex. Okay, we connect like that. So if I wanted you to draw a median, this is what you would need to draw, is we would need to know that the distance from B to Y is equal to the distance from Y to C, right? And then it's connected to the opposite vertex. We would not know if you drew a median, do not assume that it's 90 degrees right there. We don't know what that angle is. It could be different depending on the triangle. So you do not know that this is at 90 degrees. In fact, it probably is not at 90 degrees unless it's a special type of triangle. Okay, so the only thing that we know about medians is that that the two segments that it bisects, like it bisects BC. So we know that Y is the midpoint, so that B to Y is equal to Y to C. Right, so that's what's going on with medians. Now, medians, we don't have this whole like use three things to find the center, and then from that point they're equal. Medians, we just literally draw the three medians and figure out where they cross each other. Oops, not black. We're going to go back to red. So medians are a little bit easier in that aspect, in that, you know, A to Y is a median, B to Z is a median, and X to C is a median, and boom, we're done. Right? So let's talk though a little bit about medians. There is some mathematical relationships that go on with medians. So I'm just going to zoom in on the median one right here really big so we can, you know, focus our energy on that. So one thing is, if I told you that the distance from B to Y is 20, right, then you should be able to tell me that the distance from Y to C is also 20. For the same reasons that we had before, because the median goes from the midpoint, then you know, these two segments have to be equal. You know, down here, if this is 25, A to Z is 25, then Z to C is 25, and so on around your triangle, okay? The other thing is the theorem that we learned with this is pretty interesting. So if I told you that the distance from B to Z is 18, okay, so B to Z, I'm talking about the median now, is 18. Could you tell me what is the distance from B to M, and then the distance from M to Z? So for this, remember, this is the theorem, and I'm blanking on which theorem it is, but this is the theorem that says that the total distance of the median, or that the distance from the vertex to the median is equal to 2/3 the total distance. So the theorem says the distance from B to M is equal to 2/3 the total distance of B to Z. Okay, and 2/3 of 18 is 12. So if the total distance is 18, this distance is 12. And then you can either use your properties or whatever it might be to figure out that the distance from M to Z then has to be 6, right? 6 plus 12 equals 18. So you should also be able to do that. If you know the total distance, you should be able to find the distance from the vertex to the centroid. And that's what this is here. Okay, so that's the third type of centers of a triangle. Zoom back out here. That's the wrong way. All right, and the fourth type is the orthocenter. So the orthocenter is made up of the, what color didn't we use yet? Gray. Orthocenter, sorry, you get gray. The orthocenter is made up of altitudes. Nope, not altitudes. Oh goodness. Is it break time yet? Altitudes. That's a T there, right? All right, so remember, altitude is the one. Altitude means that we're going to go from the vertex to the opposite side at 90 degrees. So if I asked you to draw an altitude of a triangle, remember this is the height of a triangle. You didn't even know it was called the altitude. So you're going to go from one vertex to the other side at 90 degrees. Okay, so voila, I have drawn an altitude of a triangle. So with an altitude, we can't assume a whole lot going on with this picture, right? We don't know, you know, so we don't even need Z here because that's not at the midpoint. We don't, A to Z is not congruent to Z to C, which you can obviously see. So you can't not assume that, take that off, right? You can't assume that the angles are congruent to each other. This is not necessarily true. We don't know that, right? The only thing that we really know with an altitude is that the altitude meets at 90 degrees. Okay, so that's really all we know with that altitude. When the three altitudes are drawn, right, here's my three altitudes, and we figure out where they meet at the orthocenter, right? And that's the orthocenter right there. And that's about it. They meet at a point, and that's what we know with that. All right, so those are the 4 types of triangles. Again, I just wanted to make sure that we had a second look at them because it's a lot of information, right? You got to think about each one and what they mean. You can use this sheet for your test as a reference. I just want you to really think about and understand each one. Two quick things. One is 2 test problems or 2 quiz problems that kind of confused people. I just wanted to make sure that we talked about those too. So that is these 2. So we're talking about bisectors, angle bisectors here. And so remember, to have an angle bisector, you have to have 2 the angle bisector theorem, I'm sorry, not just an angle bisector. So an angle bisector divides an angle into 2 equal parts. But if you're trying to figure out if something is an angle bisector, there's 2 things that you need. You need the fact that the 2 from a point, D, to the angle, which is ABC, you need to know that the distance from A to D equals the distance from D to C. These 2 have to be equidistant. And they have to be at 90 degrees. They have to be perpendicular because that means it's the shortest distance. So A to D has to be perpendicular to BA, and D to C has to be perpendicular to BC. So if I look at this picture and I say, is point D on the angle bisector? Is BD an angle bisector? I cannot say that it is because I don't know if A to D equals D to C. So I only have one of the 2 pieces of information. I only know that those 2 lines are the shortest distance, but I don't know if A to D equals D to C. All right, then I go over number 17. In 17, I do know that A to D equals D to C, but I don't know if these lines meet at 90 degrees or not, making it the shortest distance. So this one also, I cannot assume that BD is an angle bisector. So I had different combinations of people get those right and wrong. Some said no and yes to either one. Maybe it was a little weird because they were both no and you were expecting them to be yes. I'm not quite sure, but I just wanted to go over that. All right, back to me. Hello. I'm also sending out with this video the activity we're going to do in class today. It's kind of a fun activity. It's something you can do on your own. So this is a clue game, and how you play it is the only thing that you really, if you're just look on your computer for all of the clues. The only thing that you really need to print out is this sheet right here. Okay, the suspects, locations, and weapons. So what you're going to do is there are 11 clues. Okay, and so let me hold up a clue. So you can look through each of those clues, okay, and solve them. So for example, this clue says find HR, right? So there we go. Find HR down here. This is an example of a mid-segment, and so you should be able to figure that out pretty quickly. Okay, so once you figure out what the answer is, which I will help you with this one. So what is shown here, OE is the mid-segment of HR. So we know, sorry, I'm trying to point upside down and I can't do it very well. So because OE is 16, we would know that HR has to be double that, which is 32. So the answer to number 5 is Mr. Brown was in the library. Okay, so what you're going to do is you're going to come to your suspect sheet, and you're going to write down Mr. Brown, number 5, was in the library, and put number 5 there. And basically, you're crossing those off as suspects. So we're playing the game of Clue, and you're trying to figure out who committed the crime, which suspect and location and weapon that they used. So from each of the 11 clues, you should be able to cross off the suspects, the locations, and the weapons. And so if you want to go ahead and complete this on your own, you're welcome to email me. It was, and this is not the answer, I'm just picking, it was Dr. Navy in the auditorium with the calculator. So you can email me who you think did it. I know that it's something we're going to do in class as a group. So if it's taking you a long time and you have other stuff to do and you're trying to catch up, don't don't stress out about that if you don't get that back to me. It's just an exercise in learning, just reviewing all the things. There is one quick watch out that I'll give everybody. There's 3 problems where you have to actually draw the coordinates and then find the mid segment. My clue to you is draw them correctly and then kind of estimate from there. So there's not, you don't need to be using the distance formula. I mean, you can do that, but to find those, you can kind of estimate based off of that. So there's 3 that have graphing on them. So that's all for today, guys. Again, anytime you have questions, please feel free to email me. I'm happy to hop on Zoom anytime. And take care and have a restful Thanksgiving. Talk to you later. Bye.